All right, 15. We're told that Macon County had a population of 53,792 in 2015. The population increases by 2.5% annually. What function can be used to model the population T years after 2015? Well, when we're told that our growth is by percentages, we're looking at basically exponential functions, multiplicative growth. So A and B automatically are eliminated. Those are linear functions. And really the only difference between C and D are the base. And the question is 2.5% growth 1.025 or is it 1.25? Well, we have to know how to take and convert a percentage into a decimal. And that's pretty simple. 2.5 divided by 100 is how we do it. And we see it's 0.025. So our only option here is C. Of course, it is growth, so it has to be greater than 1, and 1.025 is sufficient. All right, number 16, we're given an incomplete two-way frequency table. We're told about things having a brother, having a sister, not having a brother, having a sister, having a brother, not having a sister, and not having a brother, not having a sister. We're told how many people have a sister overall, how many don't have a sister, how many have a brother overall, how many don't have a brother overall. And we're told the total people are 525. We're also told that the results show that 24% of the people surveyed do not have a sister. Okay, so that would be here. And 68% of the people surveyed have a brother. The results showed that 93% of the people surveyed do not have a sister and do not have a brother. So those who do not have a brother and those who do not have a sister are right here. And that really doesn't help us fill out the table much more, so we're going to have to use these percentages. So, 24% of the people surveyed do not have a sister. That's going to be out of 525. So our first step here is taking our 24 and converting it into a decimal, which is 24 over 100 is 0.24. And then we're going to multiply it by the total number of people that we have, which I think we surveyed, move this in, 525 people. So 24% is 24 over 100. And we're going to multiply that by 525. That is 126 people. So 126 people do not have a sister. The group total for that is 126. Now we can figure out how many do not have a sister but have a brother. This plus 93 must be 126. So I'm going to go back to our calculators. 126 minus 93. That answer is 33. All right, good. Now we still have to convert this other 68% of the people surveyed have a brother. So that is going to be, I don't need these calculations anymore, 68 over 100 times it multiplied by the total, 525. That's 357 of our participants, poll participants. I'm just going to move this over here so I don't have to keep opening and closing. Have a brother. I guess I can't close it much further. So, 357 have a brother. That would go here. All right. Now to finish this up, I need to find out how many do not have a brother. So I got to go 525 minus 357. That's 168. I then also know that 357 minus 33 would give us the number of how many people have a brother and a sister. I know that 357 have a brother. Of those, 33 don't have a sister, so the remaining 324 that have a brother have a sister. I can also do the same here for having a sister but not having a brother. So 168 minus 93 gives us 75. And then I can simply sum 324 plus 75. Oops, hit the wrong button there. And that's 399. And if I have 399 people have a sister and 126 do not have a sister, that sums to 525 people. So that is my completed two-way frequency table. converting percentages into whole values based on taking the percentages, dividing by 100, and multiplying by the total values. The function h of p represents the cost for the company to manufacture posters, or manufacture p number of posters. What is the domain of the function? Well, p, posters, there's a couple things we know about posters. One, they have to be positive. We can't have negative posters. Okay? You either have a whole number, and they also have to be whole numbers. You can't sell half and quarter posters. So, our solutions here, all positive rational numbers. Well, rational numbers include fractions, so it can't be D. All non-negative integers. That sounds pretty good. Those are whole numbers that are positive. All real numbers. Well, real numbers include irrational and rational numbers. I am not going to sell you pi number of posters. So B is out. A is all integers. And if I remember correctly, integers also include those pesky negative numbers. So my only solution here would be C, all non-negative integers. All right, a quadratic is shown as 0 is equal to x squared minus 3x minus 4, and we're asked which value is a solution to the equation. Some of us can factor this in our heads. This would be x minus 4 times x plus 1. X plus 1 would give us a factor of negative 1. X minus 4 would give us x equals 4. So our answer should be D. Now, for the rest of the world that didn't factor that in your head, here's the easy way to solve this. And the easy way to solve this is going to use your calculator, graph it, and find your x-intercepts, because those are also your solutions. So y is equal to x squared minus 3x minus 4. And we look at that, we have two x-intercepts, negative 1, 0, and 4, 0. If we go back to our answers, negative 1 is an option, 4 is, that's our answer. All right, we are asked to select all the values of a correlation coefficient that suggest a strong linear relationship between two variables. Well, a strong linear relationship between two variables, our correlation coefficients are going to vary between the values of negative 1 to 1, where a negative 1 correlation coefficient is a strong negative linear correlation. That means that it's a very tight fit between, a perfect fit between the data points and our linear regression, and it's negative in that our slope is negative. That means as our input increases, our output decreases. 1 is a strong positive slope. That means that as x increases, y increases, and that all of our data points fit perfectly along our linear equation. And finally, as we move between negative 1 and 1, our strength of our correlation decreases towards 0. That means there's no correlation. That means if you try to put a linear regression on those data points, it will not work. There's no relationships between x and y. And then as I go from 0 to 1, I will see an increase in the strength. The values closest to 0, whether they're negative or positive, are tending to be weaker, and the values as they get closer to negative 1 and 1 are our strongest. Therefore, looking at our selections here, we're asked to find a strong linear relationship between the two variables. 0.8 is pretty close to 1, that's pretty strong. 0.4 is closer to 0, that would be weak. 0 indicates no correlation. Negative 0.1 indicates a weak negative correlation. And negative 0.9, that's still a strong correlation. It's saying it's a negative slope, but that's still linear. So I would say 0.8 and negative 0.09 would be our answer. All right, Juan's collecting data on a number of hot dogs sold at a hot dog stand each hour one day and the number of cars that drive by the stand in that hour. His data is shown in the table. Based on his data, which conclusion can Juan make? Well, he's going to say that an increase of cars is associated with a decrease in hot dog sales. That means that the cars affect the hot dogs sold. Well, that's probably not going to, well, maybe it is. That could possibly be the case, that more cars would lead to more, or would affect the hot dog sales. An increase of cars is associated with an increase of hot dog sales. an increase in cars causes a decrease in hot dog sales, and an increase in cars causes an increase in hot dog sales. So let's just go ahead and put this table in our calculator. I'm going to go select Add Item, and I'm going to select Table. And I'm going to enter this data in. Now that I've entered in this data, I notice that as my X value increases, my Y value increases. I've got a positive correlation here. My X value is the number of hot dogs sold, and my Y value is the number of cars. So what I'm looking at is my answers now is both our cars and our hot dogs increased together. So instantly A and C are eliminated. So the question is, does an increase in cars, is that associated with an increase in hot dog sales, or is an increase in cars causing an increase in hot dog sales? Well, that's a question. Do we know for sure what's going on, or are they just simply associated with one another? And it's hard to say that an increase in cars causes an increase of hot dog sales. It could, but it might not. But we do know that when Juan saw an increase in cars, he did see an increase in hot dog sales. So we can say that those are associated. And that would be our answer. Our rectangular park has an area of 250 square feet. The length of the park is 7 feet more than twice the width, W, of the park. Write an equation in terms of W to model this equation. So, a couple ways to do this is the area is 250 feet, so we know that. And that's equal to width times length. The length is 7 feet more than twice the width. So, 2 times the width is 2W. 7 more than that is just adding 7. And then the width itself is W. So this would be a possibility for our equation. Now, when I go through and expand this and distribute the W to both 2W plus 7, I'm going to get 2W squared plus 7W. Alright, so Julian graphs the function f of x is equal to 2x plus 5. He then moves the graph down 8 units to create a function g of x. Create a function that represents g of x. Well, we have to look at our function here. We have 2 to the power of x plus 5. Moving vertical transformations is our k value. That is going to be what's added to our function after we've done our exponent. And outside the exponent, so that's plus 5. If we move it down 8, we're going to subtract 8 from 5, and we're going to get 3. So our function should be 2 to the power of x minus 3. Now we can verify this answer by putting this in our calculator and looking at the graphs, which I'm going to do right now. So our function y is equal to 2 to the power 2, keep hitting the wrong button, 2 to the power of x minus or plus 5, that's our original equation. Y is equal to 2 to the power of x minus 3. And if we look at those functions, and I'm going to zoom this or make this a lot larger here in a moment. If I look at this, our difference here is we go through 5, is we're basically reaching close to 5 here. Here we're reaching close to 3. That's a transformation of 1, 2, or down 1, 2, 3, 4, 5, 6, 7, and 8. In this one, we're given a box plot, and we're asked to put data in here and record the ages of 9 of Yesenia's friends. All right, so we know we have a minimum value at 7 and a maximum value at 17. We see that our median is 13. We have ages of 9 of our friends. That's an odd number, so we can have even numbers above and below the median and one value on the median at least. We also know that we have a Q1, which is 9, and a Q3, which is 14. Right now I have 2 above and 2 below. What I could do is I could put another value on my median. That would still keep me at 2 above, 2 below. I could also then put another value on Q1 and Q3 and Q1. That would keep me at 3 below and 3 above. Still keeping all of our numbers equal, and one more at the median, and we're good.